Hello students. We had solved a previous year problem, part 1 of this problem in the last video. So this is part 2. So this question was asked in KTU 2018 December. So this is from module 5, stress transformation portion. Okay. So what we are solving today is the second part. So at a point in a stress material, the normal stress on a plane is 50 Newton per mm square, and normal stress of 30 Newton per mm square is acting on the plane perpendicular to it. So there are two planes, one perpendicular planes. One plane it is 50 Newton per mm square. So I hope students can recollect that 1 Newton per mm square is nothing but 1 MPa. Okay, so we will use the MPa convention for stress. So one direction it is 50 MPa. So let's say this, I'll call this as x direction. This is 50 MPa. The other direction it is normal stress of 30 MPa in compression. So here it is 30 MPa. 30 MPa in compression. MPa. Then they are telling the shear stress acting on the planes is 25 Newton per mm square. So there is a shear stress also acting. So let's say I will draw any one phase one shear stress. This is 25. So here also I will draw the opposite direction shear stress, magnitude same. Now this two shear stress forms a couple. Forces due to shear stress forms a couple and try to rotate in anti-clockwise direction. So we need a couple in the opposite direction. All the shear stresses are 25 MPa. Okay. They're asking to find principal stresses and the planes. So principal stresses we have to find, principal planes you have to find using Mohs circle method. Also determine maximum shear stress at that point. So we have to find principal stress, principal planes, then maximum shear stress. All these things we have to do. The only thing is we have to do using Mohs circle. So in KTU, when we are getting a problem of Mohs circle, graph paper will not be given to you. You have to draw it in your own answer sheet. Okay. So take an approximate good scale and try to draw this. So let's say this is my shear plane, and I will draw my normal stress plane here. So this is my normal stress, sigma. This is my shear. Shear stress, the convention that we are going to use is all anti-clockwise shear stresses we will plot in the downward side, and clockwise shear stresses we will plot in the upward sides. So that is a convention that we are going to follow. Okay. Now we have to mark points. So let's say each division is 10 MPa. So this is 10, 20, 30, 40, 50. So this is 50, 60, 70, 80, 90, 100. Okay. Now this is minus 10, minus 20, minus 30, minus 40, minus 50, 60, 70, 80, 90, 100, minus 100. Okay. Now we have shear stress, anti-clockwise shear stress 10, 20, 30, 40, 50. So 10, 20, 30, so 30, 40, 50. So I am not terming it minus. This means it is clockwise, this means anti-clockwise. Okay. So this is the convention that we are going to use. Now x direction, we will write down sigma x, x is x, this is x. So sigma x is plus 50, sigma y is minus 30. So this is stress. This is minus because it is compressive. Okay. Now what we will do, we will try to get one side. So let's say we will assume this side. So we will take this side. Okay, this side we will see. In that side, we have two stresses. One tensile stress 50 MPa. So there is a 50 MPa stress here. This is 50 MPa. And we have a shear which is trying to rotate it in clockwise direction, anti-clockwise direction. So this is anti-clockwise is downward, clockwise is upward. So this phase, if you see, you just see that phase. There is a compressive force and there is a shear force. This shear force is trying to rotate this in anti-clockwise direction. So we have to find the shear stress coordinate in the top portion. Okay. So we have 50 MPa tensile and we have 25 MPa shear stress. So this is 50, this is 30, 25. So this point is nothing but we can call this as 50, 25. Sorry. So this is trying to rotate in anti-clockwise direction. So that means anti-clockwise is downward. So this is 50 MPa sigma, and there is 25 MPa. So 25 is this. Okay. So this point is nothing but 50 comma 25. 25 is nothing but it is in anti-clockwise direction. So this one point we have got. Now second point, we will go to the perpendicular side here. This side we will see. So in that side, if you observe just that side, we have a compressive force of 30 kilonewton, so 30 MPa, and we have a stress in this direction. This stress is trying to rotate in clockwise direction. Okay, so 30 minus 30, 10, 20, 30, this is minus 30, and clockwise we have to move up 25, 10, 20, 25. So this point is nothing but minus 30, comma 25 in clockwise direction. So we have 2 points. Now we have to connect these 2 points with a line. Okay, connect to these 2 points with a line. So I am trying to connect the best that I could. So this is the best. Okay, so we have, this is 30. Okay, so this is my diameter of the Mohr circle. Now what we'll do, we'll take a protractor, we take a compass, and we will try to draw a circle. Now center of the compass should be at this point where it is meeting, where the Mohr circle is meeting the sigma axis. Okay, then we have to rotate this a little bit. Okay, then we will adjust the radius. The radius should be such that it is just this point. From this point to this point is the radius. Now what I will do, I will draw a circle. So let me draw the circle. Okay, so there is minor change adjustment I have to use. Let me see, let me do that. So just give me a moment. So approximately, it is not exact, approximately, just draw a circle. Okay, so I have drawn the circle. Okay, so I am removing the compass now. So this is my Mohr circle. Okay, and this diagonal represent the points of the stresses. Okay, so this is my Mohr circle. This center of the Mohr circle, we will see this Mohr circle center. Okay, now we have certain interesting points here. There is one point here, there is another point here. This point is what is known as sigma 1, and this is what is known as sigma 2. The importance of this point is that in this circle, these are the only 2 points where shear stress is 0. Okay, so that means these 2 points are nothing but the principal stresses. Okay, now how do you find sigma 1? Sigma 1, if you see, I can measure it as 10, 20, 30, 40, 50, something around 58 MPa. Yeah, something around 58 MPa. So 58, 57 MPa. Sigma 2 is nothing but minus 10, minus 20, minus 30, minus 36, minus 38, approximately minus 37 to minus 38 MPa. So let's say we'll say it is minus 37 MPa. Okay, so the more better you draw the circle, you'll get more accurate results. So don't worry, this approximate answer is only enough for our exam. Now, center of the circle is an important point. Okay, now we got the principal stresses from the Mohr circle. Okay, now we want to find the plane. Now this angle. Okay, so this point corresponds to this side. This point corresponds to stress in this side. Okay, so from this side we have to move this much to reach this point. So that is the angle of rotation that we need. So in fact, that angle of rotation is, this angle of rotation is nothing but 2 theta. Okay, so this angle of rotation, this is the inclination of this is the rotation that we require to get the principal planes. Okay, so we will measure this angle. So let's take a protractor. So protractor is here. Let's rotate it, keep it the center, and let's see. So I think this is okay. So 31, 32 is the angle that I am getting. So approximately 2 theta p is nothing but 2 theta p is equal to 32 degree. So theta p, that's the angle of principal stress, principal plane is nothing but 16 degree. So that is one principal plane. The other principal plane is this plus, this is 180. So that means 180 by 290. This plus, so this angle will be, this is the second point. Okay, so from here we have to add. So from this point, if you travel this much distance, you will get the second principal plane. So for that you have to get what, this is 180, this is 2p. So 180 plus 2p is your second principal plane. So that means 90 plus theta p. Okay, so we will illustrate this so that it is more clear to you. There could be some doubts for first time learners. So let's say, so this is my plane. Okay, let me take this out. So I'm taking this out. Okay, copy this. So let's say hide this. Okay, I will erase some portion here. Now we are going in counterclockwise direction, so we have to rotate the block also in counterclockwise direction. Okay, so let's do that. Okay, so this is, let's say, 16 degree. Okay, so this is the plane for maximum principal planes. Okay, so I will remove the shear because okay, so I have removed the shear stress because it is a principal plane. So this angle is nothing but 16 degree. This angle is 16 degree, what I have rotated, this 16 degree. In first sigma plane, what I get is 58 MPa. 58 MPa. How did I get? After traveling 2 theta p. So in real point wise, it is theta p rotation. So theta p rotation here correspond to 2 theta p rotation in the Mohr circle. So theta p rotation will give me sigma 1. Then from there, if I again travel 90 degree, that is 180 degree, that is 90 degree. So from here to here, 180 degree, if I 90 degree if I travel, I'll get 37 MPa here. Okay. So this, for this plane, the angle is 16 degree. For this plane, it is 16 plus 90. Okay, so nothing but in the Mohr circle, it is 2 theta p plus 180, 90 into 2, 180. To get this, so from this plane is what we are seeing. Normally, if we are measuring from this plane 16 degree, if you go, you'll get this plane. 16 plus 90 degree, if you go, you'll get this plane. Okay, so first plane you will get 58 MPa, second plane you get 37 MPa compressive stress. So this much you got. So this blocks, if you draw, then the evaluator will know that your concepts are very clear. Okay, now that is done. Now is it done? No. Principal planes are over, principal stresses are over. Also determine the maximum shear stress. Okay, so they are asking what is the maximum shear stress. So in this circle, the maximum shear stress corresponding to these 2 points. Now it is nothing but the radius, right? So this is the maximum shear stress. This is nothing but radius. If you want, if I find the radius of the circle, you can find maximum shear stress. So you can see what will be the radius of the circle. There are many ways to find. So best way is this sigma 1 minus this center, if you subtract the center. Okay, so radius of the circle is sigma 1 minus, so I'll call this center location as, so it is commonly called as sigma average. Okay, so this comes out to be 10. Sigma average is nothing but center of the circle. So this is nothing but my sigma 1 is 58 minus 10 equal to 48 MPa. This is the radius of the circle. So I have found the radius of the circle. So this is radius, this is also radius, this is also radius. So this radius corresponding to the maximum shear. You can understand here. Okay, maximum shear. Right. Now, if you want to check this, it's a 10 mark question. If you draw the Mohr circle and get these values, you should get 10 marks. But to make sure that your answers is right, you can check. Okay. So for example, this sigma average should be equal to sigma x plus sigma y by 2. So that means nothing but 50 minus 30 by 2 equal to 10 MPa. So this seems correct. So this point is correct. Okay. Now radius is given by sigma x minus sigma y by 2 whole square plus tau xy whole square. So this you can calculate. So if you calculate, what you get? 50 plus 30. 50 plus 30 by 2 whole square plus 25 square under root. So this comes out to be something around, let me see, 47.17 MPa. 47.17 MPa. So this is very, very close to what we have found here. Okay, 40 MPa. Now sigma 1, sigma 2 is also very easy to find. So this is cross checking. So I'll just write the heading here. This is cross check. It is not required, but it is, it is better for your perfect answer. Now sigma 1 is sigma average plus radius. So you can see this sigma 1 is nothing but sigma average plus radius will give me sigma 1. Okay. So this is nothing but 10 plus 47 point. So 10 plus 47.17. This is gives me 58.57.17. So this is more or less very equal to very near to 58. Okay. So this small difference is because of the accuracy of the graph, the lack of accuracy of the graph. Okay. Sigma 2 is nothing but sigma average minus r. So what is sigma average minus r in the graph? This is sigma average minus r. Okay. So from this distance, go here, then subtract r, you will get this point. So what is that? That is equal to 10 minus 47.17 equal to minus 37.17 MPa. So units are very important. If I had missed a unit, okay, you should not miss the unit. Okay, so 37.17 MPa, 37 MPa. So we got all the answers absolutely correct. Now if you want to check the angle also you can check. So I will check it here. Tan 2 theta p is equal to tau xy by sigma x minus sigma y by 2. So this is nothing but tau xy is 25 divided by sigma x minus sigma y 2 is 50 plus 30, 80 by 2 is 40. Okay. So this gives me 2 theta is approximately equal to something around 32 point something. Okay. So it's approximately coming as correct. 16 degree approximately. So this will come. I am not calculating this, but this will also come. I have checked this. Okay. So this is the answer. So in KTU, you are expected to draw the Mohs circle and get these values. So you are expected to get this value, this value, this value, and shear stress value. Okay. So this shear stress value is nothing but tau max. And if you want to know the plane of the shear stress, so from here, what is this angle? This angle. This is plane of the shear, maximum shear stress. So it is nothing but theta p plus, so this is 2 times the theta. Okay. So this is nothing but theta, 2 theta p plus 90. Okay. So in real term, it is theta p plus 45. So that is a angle. If they ask angle next time. Okay. So that's all. I hope this is very clear. We will see in another video where I will be solving another KTU problem. Thank you.